All right, welcome to section 19.1. We are going to talk about, continuing to talk about waves and types of radiation and how they kind of affect you and the practical purposes of that. So 19.1, we are going to focus on, and that we've talked about sound, now we're going to focus on light. But before we can talk about light, we need to talk about electromagnetic waves. Now, what are the two key words in electromagnetic? All right, pretty common sense. Electro and magnetic. So we're talking electricity and magnetism all in one. Now, an electromagnetic wave consists of both. So it's a wave that consists both of electric and magnetic fields. The electric field goes up and down. The magnetic field goes side to side, all in the same wave. What makes these waves really cool is, unlike sound where it needs a medium to go through, electromagnetic waves do not need a medium to travel through, so they can travel through a vacuum or space. So electromagnetic waves are possible of traveling through space. Now, we've talked about this before. How fast is light? All right, a cheetah is 70 miles per hour. Tornado, 250, all the way to the space shuttle, 20,000 miles per hour. Light travels at 186,000 miles per second. We're talking miles per second. That's how fast light is, and that's how fast all of these electromagnetic properties are. I want to expose you to one piece of vocabulary. Light, we've been talking about waves. Light can travel as a wave. It also can travel as a particle. And essentially, the one key word that I want to expose you to is a photon. And a photon is just a particle of light. So light that we can see, is an electromagnetic, a type of electromagnetic radiation. It's just one of the 7 different types of electromagnetic radiation. But light can travel as a photon, as a particle, or it can travel as a wave, and we're going to talk about both of those later in chapter 19. So that is light, right? Light and electromagnetic waves. Now, what are the different types of electromagnetic waves? There are 7 different types of electromagnetic radiation, or 7 types broken down in the spectrum. So if you look here, some of these are going to sound familiar. You're going to have radio, microwave, infrared, visible. Now, visible light's the light that you can see. Those are colors: red, orange, yellow, green, blue, indigo, and violet. And then on the other side, we have ultraviolet, X-rays, and gamma rays. And all 7 of these have practical purposes in our society. But they are all waves. So, a couple things in general about the electromagnetic spectrum. You will note that radio to gamma ray, the frequency does what? The frequency increases. However, the wavelength, if we go radio to gamma wave, the wavelength decreases. Radio waves are actually quite long. Right? So we have low frequency and high wavelengths with radio, and as we progress across the gamma ray, we get very high frequencies and short wavelengths. Typically, the shorter the wavelength, the more energy the wave can have. So typically, these on the back end over here with shorter wavelengths, X-ray and gamma ray, are more harmful to humans than microwave and radio waves. And we're going to talk about practical purposes for each of those. So, again, the 7 types of electromagnetic radiation: radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. You're going to have to be responsible for at least knowing one thing that we use in society that revolves around each different type of radiation. So we have radio waves. Radio waves, common sense. They're used for satellite communications. They're used for telecommunications like walkie-talkies, CB radios that truckers use. All of those things use radio waves, AM and FM radio. Now, does anyone even listen to AM radio anymore? All right. Anyone ever turn the station to AM, listen to it? All right. What's the difference between AM and FM? AM is the amplitude changes. So the wave looks like this. Like that, where the amplitude changes. Where in FM, the frequency changes. So an FM wave is going to look like this. All right, amplitude stay the same, but the frequency change. Where in an AM, the frequency is going to stay the same, but the amplitude of the wave is going to change. So, what do we use radio waves for? Real life, we have radio waves are used for listening to radio. And remind me in class, we are going to look at the ability of a cancer cure through the use of radio waves. We're going to watch a video in class about that, so remind me to do that tomorrow. All right, next up, the three ones that come after radio waves. We have microwaves, infrared, invisible light. Microwaves, what do we use microwaves for? Very common sense usage. All right, we usually heat food. All right. Microwaves also used for radar. How does microwave work? Essentially excites water molecules it excites water molecules in the food, therefore heating them up, therefore making your food warm. So that's how microwaves work. Infrared. Infrared's going to be abbreviated IR. Infrared is heat. All right. Anytime your body senses heat, it's infrared. So below here I have a scan of a human. All right, that human scan then is broken down into colors by temperature. The darker the colors, the cooler the temperature, the brighter the colors, the warmer the temperature. So you can see the reds and oranges are where the body is the warmest, and the blues and greens are where the body is coolest. Kind of an infrared thing. You've probably seen infrared before. The military uses infrared a lot. Visible light. That is the light you see. Roy G. Biv. Those are the 7 colors that you can see. Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. So we have radio, microwave, infrared, visible. What are our last 3 used for? Ultraviolet, tanning. All right. Tanning. All right. You may expose yourselves to ultraviolet light and your body turns tan. It is not natural for your body to change colors. Hence, getting tanned at all is not healthy for you. All right. I do not want my body to change colors. So ultraviolet light, the sun gives off ultraviolet light, and UVA, B, and C. We're going to read an article about the importance of using sunscreen and UVA, B, and C tomorrow as well. Ultraviolet rays also kill food. They also disinfect air. You find a lot of ultraviolet light in hospitals where they are performing surgery, so they can disinfect the air. It would also be smart to put those on planes and run your air through ultraviolet light prior to going back into the cabin to disinfect the air. X-rays, very common sense, broken bones. They're also used at scanners at airports and other places to detect bombs or other weapons that may be in luggage. And then lastly, gamma rays. Gamma rays help kill cancer cells. They check building structures after earthquakes. They might be using them in Nepal to test possible structures of buildings to see if they are still stable and able to enter. So, 7 types of electromagnetic radiation. First thing, what's the key in electromagnetic? Electricity, electric, and magnetic. So you have 2 fields, electric going up and down, magnetic going side to side, all in the same wave. Then they make up 7 different types of radiation. Radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. And those are the 7 types of electromagnetic radiation you're going to have to know. This is Mr. Klennert, and this concludes section 19.1.